Okay. Circumstances are beyond human control, but our conduct is our own power. Good morning, everyone. It's my pleasure to welcome all of you to a webinar on scope of engineering and insights on robotics conducted by CIT in association with Just Robotics Bengaluru. I cordially welcome the esteemed management of KES, Principal, Resource Person Mr. Brijesh, Convener Dr. Kavita PC, HODs of all departments, staff of CIT, and all our dear students who have chosen Coorg Institute of Technology as their sanctuary of learning. At CIT, we endeavor to establish quality in our students where excellence is driven by values and success is strengthened by ethics. I now request our respected principal, Dr. Baswaraj M, to address our students.
Thank you, madam. So very good morning to all. It's a great pleasure to welcome our Honorable Director, Sri M. Timaya of Kodugu Education Society, Kodugu, the CEO of Just Robotics, Bangalore, Mr. Brijesh, Dr. Kavita Madam, the convener of this webinar, my dear colleagues and my dear student friends. So I'm extremely happy that CIT is conducting a webinar on a scope of engineering and insights on robotics. So we know that the field of engineering plays a vital role in the field of in everyday life of the human being for a better comforts. Depending upon the application of any task or a work, the engineering courses like mechanical, electrical, electronics, instrumentation, and computer science are applied to complete the task at any work in the most efficient, effectively, and most economical way. That is, we express the engineering, we define the engineering in the threes. That is, it should be in a most efficient, the work has to be completed most efficient, effectively, and most economical way. And using this, and we are applying these applications in the field of robotics and automation. And we are aware that the robotics and automation is an interdisciplinary course. And at present era, this course is used in every field of engineering. Robotics engineering is about designing, structuring, and building of robots. Then what are the robots? What are the applications? What are the uses of robots or the application of robots? Using the basic principles of the robotics and automation, and we are manufacturing robots for different applications, and it has been used to work that needs an extra precision, especially in the manufacturing sector, also in the medical applications for the operations, and it's also been used in the nuclear science, the sea explorations, transmission of the electrical signals, and the designing of biomedical instruments. So I appeal all the students to take this benefit and use the applications for the practical use in a day-to-day applications. And as you know that Mr. Brijesh, the CEO, and he has worked in the field of the robotics and automation from the last 10 years, and he has conducted several workshops for students of NITs and IITs, and some of the university also. So finally, I thank our director, Sri M. Timaya, for accepting our invitation to inaugurate this webinar. And also I thank Mr. Brijesh for accepting our invitation to be the resource person. The convener to one and all. Thank you.
Yes. Thank you, sir. Learning is an endless process. The more we seek, the more we find. Learning from the experience of luminaries is a sure way to succeed in life. I now humbly request Shri M.M. Timaya, Director KES, to present the inaugural address.
Good morning, everyone. I am very happy to be here to inaugurate this webinar on a very relevant subject, that is robotics. And I also take this opportunity to say a few words to the participants who I am told are mostly first year students of CIT, as well as those who have just enrolled to become students in this college. First of all, let me congratulate you, all the students, for two things: for selecting engineering as a field of study and for future career, and for selecting CIT as your college of choice. On both counts, you have made very wise decisions. Firstly, what is engineering? During your 12 years of schooling, you have studied science and mathematics as two of the important subjects. But you did not apply it for solving problems or finding solutions. It was mostly theoretical. The physics you learned about the forces of nature. The chemistry you learned about the elements and the materials were all very interesting subjects. But you must have wondered, why am I studying all these things? Oh, but it is there in the exam, I must study. It was not so. Now, when you come to engineering course, you will realize that all the science and the mathematics that you learned along with it will be very useful. To apply scientific principles in a work situation, in a technical solution, you apply scientific principles and you need mathematical tools to achieve the solutions. So all that you have learned till now will be of immense help to you in future also. I tell students always, that is why, that whenever you study a subject, please do not think that you are studying a subject only for the sake of writing the exam, the next exam. That is not so. Almost all the subjects that we study will be of some use. The knowledge will be of some use in future. So always think that when you study a subject that I am gaining knowledge and I am going to use it sometime in future. And coming to CIT, you have chosen this wonderful institution located in a beautiful rural setting wisely. Let me tell you why. You might have heard of big colleges in cities, but that will be a huge crowd. The teachers will not know who the students are. The classes will be like very, very big crowds. Somehow you go there and you'll get through and get your degree at the end of 4 years. But CIT is a college which is very well equipped. The kind of facilities we have for the number of students is extraordinary. Colleges in cities with 10 times our strength may not have as many facilities in terms of laboratories, workshops, library, all these as we have. And most important, since our classes are small, our teachers will be able to give you personal attention and you will do very well in your academic career. Let me tell you one or two anecdotes about this. Several years ago, I read an interview given by the famous Dhirubhai Ambani, the great industrialist of India and father of Mr. Mukesh Ambani, whom you may all have heard now. Dhirubhai Ambani built some fantastic factories, world-class factories, world-class refineries. He was not a highly educated person, nor was he a man of technical background. So the interviewer asked him, "Sir, what kind of people do you recruit?" He gave a straightforward answer. He said, "I recruit engineers with a rural background." Then I thought, why did he say that? That is because, you see, in rural areas, what happens is we do not have experts. We do not have technical help to solve every problem. So people living in the villages, they try to solve problems with their own common sense because there is no technical help available. In cities, you have any problem, you call the relevant technical expert and he will do the job and go. You are not involved. But here we are forced to find solutions on our own using our own intelligence and common sense. So students who have studied in rural areas, who come from rural backgrounds, when they go into a job, they do extremely well. Another incident happened about 5-6 years ago. I was traveling from Coorg to Bangalore, and in the Volvo bus, I met a former student of CIT. Her name is Neelamma. She was one of our very good students, an all-rounder. She was good in sports, good personality, and also good in studies. And I asked her what she was doing. She said, "I work for IBM." Very good. Then after talking to her for some time, I asked one question. I said, "Neelamma, tell me, you are from CIT, from a rural background. In IBM, there will be students from top universities and colleges. Do you feel handicapped in any way?" She replied that, "Sir, I think it is the other way. I think the students from all those big colleges and cities, they feel handicapped because I can face any situation. They may not be able to face all. They may do well in an urban setting, but not in all situations." She was so confident, and she was doing very well at that time, and I'm sure she must be doing even better now. Let me tell you about my own experience in life. I studied in rural schools and colleges in Mysore, not a big city. Then I worked for one of the biggest organizations in India, a bank, where the recruitment test was written by thousands of students from all over India. But those days, about 40,000 students used to write the probationary officer's exam for SBI. And many of them many from even IITs, Central Institute of Technologies, top colleges in the country. And then we were selected. And there was a 2-year probation or a training period. I did not find any problem going either in the selection or in going through the training. At the end of training, somehow I don't know, I got posted to one of the most important departments in the head office, which was looking after the large companies, the most important customers of the bank. While many of those students who had come from famous colleges, they were sent to branches to work as assistant managers or field officers, all those. So I'm saying all this, dear students, to assure you, don't for even a moment think that you are entering CI engineering, you are joining CIT, you are not in any way going to be handicapped in your future career. Instead, I think it will be a great advantage. You use all the opportunities available here, the facilities available here, and the experienced teachers we have, and get personal attention. It is like getting customized education. You have any problem, you will be able to approach the teachers, clear your doubts, study well, and do well in your engineering course. Thank you.
Thank you, sir. We are highly indebted to you for your words of wisdom. Time is not measured by the passing of years, but by what one does, what one feels, and what one achieves, said Jawaharlal Nehru. We have with us Mr. Brijesh, CEO of Just Robotics Bengaluru, the resource person of today, a storehouse of knowledge to enlighten and inspire our students. I take this wonderful occasion to introduce Mr. Brijesh before you all. An entrepreneur extraordinaire, an educationist in the waiting, a passionate teacher above all, he has been working in the field of robotics and automation for just an albeit close to a decade now, from building advanced robotic systems to conducting workshops for practically everyone under the sun, be it kids, teachers, and faculties across the board. Just Robotics was recently announced winners of the Karnataka state government's coveted Elevate Call 2 program under the Startup Karnataka program for their dream project, Make Mini Robots, aiming at democratizing STEM education. We are very happy to have you with us, sir. I now hand over the session to Mr. Brijesh. Over to you, sir.
Thank you, ma'am. I'm just doing a little bit of settings here. Good morning, everybody. First of all, I thank Timaya sir, Basraj sir, Kavita ma'am for giving this opportunity and making me talk to the students, the fresh engineers who are going to be engineers in another 3 to 4 years. In fact, morning I was just sitting down and trying to figure out how it would be if I would have been sitting in your place about 10 years ago, or 13 years ago, because I started my engineering in 2007 in MVJ College of Engineering. So I was just imagining what kind of technology was available back then and how we would have done or dealt with the situation that we have today in terms of the pandemic, the online classes and all of that. Because back then we didn't even have a smartphone. And this is not like 50 years ago or 100 years ago. This is just about 13 years ago. And my hairs are not even gray. Like I'm not talking of 50 years of experience. I'm just talking of very minimum of 10 years experience. And you can probably consider me like your college senior who just maybe passed or even a final year student. Because I've been working with students and especially engineering students and school students for close to a decade now. And I've seen that everybody comes in with a lot of enthusiasm, with a lot of eagerness to study and learn and do things. But eventually they get carried away with different other things and then they don't achieve what they intend to do or to their fullest potential. So my intention today is to give you a brief of what robotics is all about and why it's not a very complex thing. And because you've seen it every here and there, just because you do not know robotics or you've not learned robotics in a structured way doesn't mean that you have not interacted with robotics. Most of you would be surprised to know that we have some or the other way interacted with robots in these years of our lives. And that's something that I would want to cover. And also I'll give you a brief of how engineering education was back then and how it is today and how CIT is helping students make the most out of their 4 years of engineering at CIT. I have a presentation to share, so I'm just gonna share my screen. So it's more of a formality sake. I mean, I can keep talking, I can keep showing things, but if I am not able to connect you to what I intend to convey, it'll be difficult. So this is what is, yeah. Okay, so engineering and robotics go hand in hand. Why I say this engineering and robotics go hand in hand is primarily because robotics is not a branch of engineering. Okay, so we have electronics and communication engineering, computer science engineering, civil engineering, electrical engineering, and then mechanical engineering. We have different branches of engineering, but very recently did we get something called robotics and automation engineering, and very few colleges in Karnataka and India have this as a specific branch. Now, even before this, we used to learn about robotics. And now, how do we say so? A very simple way to identify what robots are is to ask the simple formula that goes like this. sense, think, and act. In fact, I'm wearing a shirt that says sense, think, and act. Uh, Anything that can sense its environments, anything that can think and process information, and anything that can act upon that processed information can be termed a robot. So a robot is a machine that can sense its environment, sense the surroundings. It can process information and also act upon the information that it takes it. Now, to sense, we all have 5 sense organs, which is eyes, ears, nose, skin. To process information, we have a brain to think, and then to act, we have our hands and legs. Similarly, on a robot, there are sensors that do sensing of the environment. Cameras are good sensors, temperature sensors, gyroscope on your phone, where you turn your phone, the screen automatically rotates. That's called a gyro sensor. So there are a lot of sensors present, and the sensors keep accumulating data. Now there is a processor. Processor is a motherboard. You can call it a computer. You can call it a controller. It's where all the sensor information is processed. Okay, if I turn the phone left, my screen has to rotate. That's what the processor does. And what are actuators? Actuators are things like motors or any output devices that actually have some kind of motion in them. So it moves, right? So I mean, I'll leave the floor open to all of you to ask this question as to give me an example of a robot that you have seen. I mean, this question is open to everybody. Give me an example of a robot that you have seen. I get answers telling transformers or humanoid robots and all of that, but something that you have seen and maybe used. Anybody? Okay, I'll just keep going. So look at this picture and then you will know. How many of you have seen this? Washing machine? A microwave oven? Air conditioner? So these are robots around us, but we fail to identify them as robots. So let's look at washing machine. Does the washing machine have sensors? Yes, it does. So it will tell you if the tap is not on. It will tell you if you have not loaded clothes. It will tell you when once the work is over. Does it have a processor? Yes, it does have processor. It thinks, it does. You say 5 minutes, it runs for 5 minutes. You say 1 hour, it runs for 1 hour. So it has a processor that is thinking and doing some action. And does it have an actuator or a motor or a thing that moves? Yes, it has a motor that does the washing function. Similarly, you have, there is somebody who's trying to play around with pointers. Just give me a moment. Okay. Yeah, so this is with respect to the robots. You have washing machines and air conditioners and microwave ovens that are looking like robots. But at the same time, you also have robots that are a little advanced, something like this. What's this? I mean, I'm happy if you students are able to interact with me, because I don't want it to be a very boring seminar and then half of you sleep off, or you're here just because of the attendance. Anybody who's able to identify this? You'll get 10 extra mark in your internals. Nobody?
Sophia.
Yeah, it's the Sophia robot.
Sophia.
Called, yes, thank you. Called one of the most advanced AI systems. AI is artificial intelligence systems. And I mean, I would say the Alexa on your phone or the Amazon Alexa is also as advanced as Sophia. But the challenge being, there is a visual expression. There are at least about 50 plus motors and actuators on the space that does the job of controlling those eyes and nose and lips and everything together to be able to depict how a human being does facial expressions. So this is Sophia. This is a robot that's doing a push-up. These are all humanoid robots. Why I'm showing you the internal of this robot is to show you how it takes so much effort and so many motors and things together to be able to even do a simple action like uh, lifting, bending your finger or turning your head. It requires so many actions. Now, this is supposed to be one of the earliest of robots. So this is called the Asimo humanoid. So if I'm not wrong, it was 1990 when this was first launched. So it took them a good 10, 20 years to get to what Asimo could do. And this research is going on ever since. In the last 30 years, Asimo has been able to move from just able to stand up on its own to be able to walk. And over the period of time, it is increasing its speed. So it is similar to how we take time to stand up on our legs and then learn to stand or erect and then start moving. It takes us a good amount of time, right? So same case with the robot research also, where to get you to stand somewhere or build a robot that could stand will take a lot of effort. These are robotic arms used in industries for various purposes. So what you see on the right is a ABB robotic arm. Then on the left is Universal Robots. On the extreme left is the Fanuc robot. Now these are used for various applications. Now most of your cars and chassis are manufactured using these robots. So what you see here as the ABB robot is actually a welding robot, a spot welding robot. You can put any kind of actuator in the front of the robotic arm to do any function. You can do pick and place, you can do welding, you can do soldering, you can do things like sorting when you won't have to sort things. And with respect to this, if you look at how its application is, this is a KUKA robot and a plant where it is manufacturing cars. And this is not something that is happening now. This was existing about 5-10 years ago also. So I'm not talking of 2020, I'm talking of 2010. This existed even in 2010, where the entire shop floor manufactured cars continuously without any human being coming in. Okay, such a automation is to an extent is available in India also, where there are different robotic arms that come into picture. They set up a plant. For example, if you go to Nissan in Pune, a similar kind of a plant exists where everything is done by machines and very minimum, say maybe once in a month, somebody comes in and does a bit of cleaning. And then again, they run the machine, they close the shop. The robots do all the function to an extent where every 5 to 10 minutes, you will have one car coming out of the factory. So that level of automation robots do. We are a country of 1.35 billion population or close to 1.4 billion population. Why do we need automation? So that's something that we all ask. And as a world also, right? We have so many people, why do we need automation? So if you look at it further, you will realize that automation is the only way to ensure that there is very less entropy. When I say entropy, it is room for error, to ensure that you are being very efficient, being very advanced in what you're doing, time saving and cost effective. That's the reason why things are automated. And whether you like it or not, whether you say, okay, jobs are being replaced by robots and all of these things, whether you like it or not, you have come to a stage where the robotics revolution is happening. And it is something that will go on forever and ever. You have to catch up. Okay, now robotic revolution is happening and we have to go up. In fact, when Timaya sir was telling about how things were at SBI, I was just thinking of certain anecdotes that people used to give me when they said when computers were just introduced into the industry, like banks and offices and all of these places. Computers was right then introduced. And then what happened, a lot of people started resisting, telling, okay, I will lose my job. I will lose work to do. I will not have work to do. Computers will be replacing human beings and all of the thing happened. But today, the computer industry is one of the largest employment services in India. Like they provide employment to a large sector of people, because eventually you will need people to run robots also. It can be automated to one extent, but you will eventually need people to learn robots. And that's the reason why you learn robotics and engineering. Okay, cool. What this robot is, I'm not sure if you've seen this before, but it is actually an autonomous robot. When I say autonomous robot, it is like a self-driving car. You tell it to go to a particular place, it will go. It has LiDAR, a simple way of looking at it is a radar, which detects obstacles around the robot. And you tell it to go from point A to point B, and the robot does it. And these are indoor robots inside a shop floor, inside a factory, inside a classroom, inside an apartment or office is where these robots work. And there is a robotic arm on top of the robot, which will do some functions for it. So this is eventually what you look at as a humanoid. It does the same function as that of a human being, but it doesn't look like a human being. And it is not necessary that all robots should look like a human being, because at the end of the day, for me, it's more important to ensure that the function is achieved, what I need to do, than how the robot looks doesn't matter to me. So will this move? Yes, it moves. Will it pick and place things? Yes, it does. So it does every single function that a human being does in a shop floor or a factory where it has to do certain functions. This robot does it. So do not take out that impression out of your head that every robot that you see should look like a human being. All right. So once you look at how these robots are in the indoor perspective, then there are certain external robots. I would like to go a little deeper into this particular robot, because we also build such kind of robots at our facility here in terms of autonomous robots. Now, this is called a Husky robot. It's one of the, I would say, a pretty advanced robot currently available in the market, which has autonomous navigation capability. So what you see here, the gray part is actually a LiDAR. It's a LiDAR which does obstacle detection. This is the same camera that's available on your self-driving cars, which detects obstacles around the robot. And it's a four-wheel drive, like your Jeep or your a four-wheel drive vehicle. This also has four wheels and it's driven independently. There are wireless transmission systems on this corner here. And there's an onboard battery. There's certain cameras that does function. This is a camera that actually detects anything in the front. And there are things that it does, which means now if you tell this to go from the entrance of the college to maybe the hostel, this robot does it. And what happens if somebody comes in front of it? It'll automatically detect, detect that person, and then it turns around and navigates around it. So these are the next generation of robots which will be used for transportation of goods, delivery, and all of that. Now, you might ask, what about drones and all of that? Yes, of course, they're also there. They are aerial robots. These are ground robots. This is in shop floors, in factories where you're moving trolleys, you're moving things, pallets, which house objects. And today, you're able to get deliveries from Amazon in just one day because robots are doing it. It's not because there are human beings ensuring that you get your parcel or your courier. It's just because robots are automatically picking up things that needs to be packed. It packs it and then gives it to the shipping area, and then it is shipped and it comes to you within a day. And this is the reason why every single sector today, be it education, be it factories, be it the automobile industry, or be it healthcare industry, robots are taking over eventually, and primarily because it's more efficient and it is more effective and saves a lot of time, because today time is money, and that's the importance of robots here. Okay, yeah. So I did with respect to robots and what I had to teach about robots, and telling you that how important robotics is and why you as students today are learning engineering this way. Hold on, I just missed this slide because I wanted to come to it a little later. There are 4 parts to robotics you have to remember. One is the mechanics of robotics, or I would say design of robotics. So this will include measurements, designing, 3D modeling software, drawing, figuring out, okay, the size and shape of the robot and how it should look, what should happen, what will be the structure of the robot, what material goes into the robot. The second part is the physics of robots, the physical aspect of robots, where you're talking about the mechanics. Say, for example, force involved, what is the RPM, what kind of tools I need to use, what is the center of gravity of the thing. And I'm not talking of anything that you've not studied in school. I'm still talking of the school syllabus and nothing beyond school, be it the first year students or the second year students. I'm still talking of things that you studied in 7th standard, 6th standard, 5th standard, about pulley, about force, fulcrum, levers, about rotary motion, linear motion, mechanical structures. So all of these things you've already studied. These are called the fundamental of robotics. When you put all of these things together is what forms robotics. And then comes electronics. This is a subject that you've not studied in school. You've not studied in school except for something like Ohm's law, V is equal to I into R. What is voltage? What is current? What is resistance? That's the max that you have studied in school. But going further, you'll also study about IC, transistors, sensors, and all of that. So that's the electronics part of robotics. And then comes the most interesting and today the most one of the most craziest branches of engineering, I would say, is the computer science engineering, where we talk of programming and all of that. So does that mean that you as a mechanical engineer should not know programming? Definitely not, because whether you are a mechanical engineer or an electronics engineer, you are still taught programming all through your engineering, because programming is a very critical skill set today, irrespective of what branch of engineering you are in. Electronics engineering, yes, you learn programming. Uh, Design engineering, yes, you do learn programming. A lot of automated tools work that way. So robotics today has become an interdisciplinary branch which gels your computer science engineering, electronics engineering, mechanical engineering, and other structural engineering like civil engineering and say automobile engineering, and all of these things together in a way where it comes together. Especially, and another thing is electrical engineering, in a way where you are able to bring out a very beautiful product which solves problem in real life and using the engineering knowledge that you study in college. Okay, so I'll give you a good brief of what happened during my engineering. So if all of this is boring all this while, the next 15 minutes is going to be really interesting, primarily because I would like to share my journey from in college to what it was. So I was somebody who was sent to engineering, not because I wanted to become an engineer, because my mom felt that I could become a great engineer. Okay, otherwise I would have probably done biotech science and gone. And my mom was like, no, you will do engineering because I've seen you from child where you have the skill set to become a good engineer. I said, okay, fine, I'll get into engineering. And I got into engineering. This is my team. On the left is Rohit, Vibhav, Tabrez, and then that's me on the corner. Is it that I always built robots? No, I have attended a lot of workshops, attended to learn robotics, to understand. So this is one workshop I attended in my final year of engineering to learn about image processing and how you use processors and how you build robots using image processing and functions. So this is my team. This is a final year of engineering. This was my team which participated in Tanjore Shastra University, where we were building the robot that you see in my hand is actually a small car, which we actually build bigger ones today. This is what we had built, and we won the first place here. This is one of the longest all-terrain tracks in India back then, in terms of the college robotics is concerned. This is one of my first competitions, which was in Anna University, Chennai. So where was I when this was happening? I was in first year, end of first year engineering. It was almost like the Jan-Feb of my first year, which second year, first year, where we were just finishing our semester exams and getting in. And that's where we went to participate in Anna University. This was a little after that, just about maybe a year or so. This is one of our first medals for VTU, where we won 2 robotics championships. What you see otherwise is my seniors in college, Gaurish, Rajshekhar, Naveen, and Vibhav on the right extreme. This is right in second year. Imagine we are right out of college, PU, and just get into engineering college. We don't even know what engineering is. I didn't even want to do engineering. And we start participating in robotics competitions and start building robots. And we just won a gold medal at the college level, I mean the VTU level. So this is something that was very exciting, and that's when we started loving engineering all about. This particular picture is from somewhere in our third year, and it was taken at about 3 a.m. in the morning. I'm not joking, but it was 3 a.m. in the morning. That's the reason you will see all our eyes are like that. That is when our first autonomous robot started working. We tried a lot of things. We tried a lot of things. What you see in our hand is one of our first robots that we built, which was fully autonomous. Like, it could follow a line, and everything was something that we learned and did from scratch. This is our college team. So did we do robotics all alone? No. We used to ask our friends, our classmates, our juniors, and everybody to come, let's build robots, let's go, let's participate in competitions and do things. This was in Vellore Institute of Technology, VIT. So half the time we were out of college, participating in competitions and building robots, and our teachers were very encouraged about it. We used to hear a lot of other college students coming and complaining, telling, hey, we don't get attendance, we don't get support that you guys are getting. And our college was so supportive about it. And I see the same thing happening with Coorg Institute of Technology also, in terms of the support system that is in place, in terms of what is capable of. So we had got permission to use our mechanical labs, though we were electronics engineers, and build robots. And our computer science departments helped to write specific programs that we needed. Okay, this is something that we built in our final year of engineering, where we built a track for other college students to come and participate in competitions. So this is my team with juniors and all of them in place. So why I'm giving you these pictures and perspectives is engineering is not all about sitting and learning about 8 subjects every semester and writing exams and finishing your practicals and going for the next 4 years. For you, it's going to be a lot of fun, a lot of activity, a lot of exposure. This, nobody told us you should use the college ground to do this. We spoke to the director, the principal, and asked their permission to say, we want to do this, we want to do this kind of a competition. If you see this picture next, where is this? Hold on, I think I missed one picture. Yeah, this picture. This is where we and our seniors together organized one of the first technical fests in our college. It was one of the first technical fests at college. So all colleges have cultural fest, where other college students come participate in dance competition, that competition, this competition. But this is one of the first technical fests that we as students conducted. We told the college, we've been going for a lot of competitions. Why don't we do something on our own? And this is when we invited a lot of colleges all around India to come and participate in our college. And what you see here is something that we developed, built during this particular fest. So what I'm trying to tell you is, if you take the lead or the step forward, your college is there to support you to do whatever you want. The next 4 years for you is going to be, I would say, a golden period in terms of your learning, the exposure that you would get, and the opportunities that you will come across and skill sets you'll develop. Because tomorrow, when you go to an interview room, if your objective is to get a job, if you go to an interview room and tell them that what you see around is something that I built for this college or I built for this institution, that is a much better way of putting yourself instead of looking at how you could just pick up a job. This is a classroom. We were about 9 of us sitting on one bench. So this is the kind of fun that we used to have in classroom and class. This is in our final year. This is even when I was in final year, we got to present our robot in Delhi. This is a all-terrain vehicle that we built. It is called a soldier assistant robot, where we used to carry load for soldiers on board. 2014, I started Just Robotics along with my teammates to be able to build robots and also teach students the fun of how you could learn robotics by building robots. These are my students who build drones, who learned building drones, with all the speculations about the drone industry going here and there. I've had wonderful, fantastic students. These were all in 8th standard, where they built their own drones, understanding everything right from scratch. This is one of their autonomous robots that they built when they were in 9th standard. Not a joke. This is not an engineering college project. This is a school project. And the level of engineering is beyond any engineer could even think of. Okay, I'm not joking. It is only because those students put effort in the direction that they felt it was necessary. Not because somebody thought, I didn't teach them anything. They learned everything on their own. I just told them, gave them the directions to go in terms of what has to be done, how it could be done. So what lies ahead of you in the next 4 years or 3 years in engineering is that time that you get to figure out what kind of problems exist in the world and what kind of what do you do in terms of solving those problems. So when you try solving these problems is when you actually become an entrepreneur and you start giving jobs to people than just becoming a job seeker. So the next few years for you should be something that you would see eventually as a moment of finding problems around you. Like how Sir was telling, there are a lot of challenges around in and around even Coorg or any rural setup or a semi-urban setup where you could actually as engineers solve those problems for them. It could be automating their farms. It could be trying to bridge the supplier and the demand and supply chain, or in terms of building structures that could resist rain and floods and all of that. So these are things that you can actually sit and do right here at a place where knowledge is given to you in a way where it's not restricted at all. To understanding that the next phase of engineering that you're going to learn is to be solving somebody's problem. There are a lot of problems that exist in the world, and you as students are supposed to be problem solvers. I have okay, so this is done. Okay, this is my team now. A few people are missing. So we build autonomous robots for warehouses. We also do education. We also build robotic kits for education, all that. So a lot of things happen at Just Robotics, and I'm more than happy to be able to share these things with you. So coming to almost the end of my talk, or hopefully I've inspired you all. The robotics revolution you see is evident. It is happening, whether you like it or not. It will happen and it will go on, where more jobs will be replaced by robots, more things will be done with automation. But at the outset, you should always remember that there is something beautiful that a human being can do, which a robot cannot do. And that's where you have to be. If you have to be that one person who's gonna tell the robot what to do, then you have all the opportunities in front of you to be able to do that. Now, with respect to how to learn robots and robotics and how to go about it, all of it, CIT has taken a wonderful initiative in terms of setting up the state-of-the-art robotics laboratory. You all could visit, and we're trying to work to it in a way where you also have a good amount of supportive seniors who are also taking the lead to help you do things. So you can actually interact with them and see how you can do things. So the lab is available for you, where you have to just inform us when you want to use the lab or what you want to learn. And the lab would be made available to you in terms of anything that you want to build. Start looking at engineering in a way where you can start attending competitions. There are a lot of college technical fairs that are happening. Maybe we have a situation here where we don't know how it's going to be, whether we would have live classes in college for the next few months or not. But this phase is going to get over very soon. You'll all be back in college in maybe a very short span of time. And you'll all have the access to the kind of technology that we have put in terms of the college lab. So I would request, or I would make probably an advice to all of you to make use of what is available. Do not worry about what you know, where you come from, how good you are, how much you'll be able to unlearn. What you need to think of is you have 4 more years, and that 4 years is good enough for you to make anything that you want to be. And I'm here as a standing example, and there are many more, not just me, there are many more who have turned those 4 years of engineering into their one of the most beautiful things that they could ever do. Have fun, do everything that you could do as students, but at the same time, remember your responsibility as an engineer is to solve problems that exist in the world. And if you can start doing it from day one, then you'll become better engineers than most engineers who come out of engineering college. So with this, I end my little bit of yarn session. You have any questions, you can ask me. Feel free to ask me any questions. I don't have restrictions that way. So this is my details in case you want to contact us sometime later. This is our details. So any questions, I'll be available to take up right now. You want to message me the question if you don't want to ask out here in public. Yes, you can message me the question and I will answer that question.
So Brijesh, now all the students are there at their home. Can you support in building the robots, they being at home?
It's possible, yes. So we have one kit that we can actually provide you. What I'll do is I will just send it across to, or I can in fact show you. Yeah, so this is the kit that we have right now. So this is primarily we're looking at getting somebody to get started with robotics in terms of understanding the nuances of robotics. And this is the kit that is available. I can probably give across the link for you to buy this kit if you want, so that you will get this at a very discounted price for you to get started with robotics. Now, this will involve the programming aspect. It will also involve the sensors. It will also involve all the mechanical tools required for you to build it. And this is primarily focused at ensuring that you get a good hands-on on robotics before you come to college. Even the college has a couple of these kits in the lab, but just that you're at home and you will not be able to do anything hands-on. You can get started with this kit. It'll cost you about 4,000 change. But yeah, we can look at how we can give up the link for you, because the entire program is structured at about 14,000. But we can give you a specific discount on the kit, and you can get the kit and then get started. So this is one option available. Otherwise, you can drop by to college and use the facility at the college. Ma'am, I'll send you the link for this kit. So you can share it with the students. Whoever wants to get the kit home, they can get. I will send across the videos and links required to get started with this kit. It does about 4 or 5 functions as a robot. So this is one thing I have right now. Otherwise, there are a lot of courses available online in terms of learning robotics and all, but there is no such session right now which does both practical as well as theory. Most sessions are only theory-based sessions. There's no course right now available which gives you a hands-on kit. So yeah, so that's one thing that's possible, ma'am.
Okay, thank you, Brijesh. We'll do the needful.
Okay, thank you, sir, for the very interesting and enriching session. With this, we come to the end of today's session. And I now request Dr. Kavita PC, Webinar Coordinator, to thank everyone.
Good morning. It's my privilege to propose vote of thanks on this occasion. I express my sincere gratitude to our chief guest of today's program, Shri M.M. Timmaya, Director, Kodava Education Society, for motivating the participants and for all the support. I thank our beloved principal, Dr. M. Baswaraj, for all the support. My cordial gratitude to Mr. Brijesh, CEO, Just Robotics, Bengaluru, for sharing his knowledge and providing insight on the robotics. My cordial thanks to all the participants for joining this event. Hope the session was useful and had good value addition to your career. I advise dear students, it's the right time for you to upskill. And as you all know, plenty of resources are available on the internet. And also we will be hosting such programs quite often. So please make best use of this opportunity, and also feel free to suggest and contact us anytime. We will try our level best to support you in all possible ways. With this, I wish the participants all the very best for your bright future. I thank Professor Kaveshri K.A., Department of English, MC of this program. I also thank our esteemed management, HODs, and the staff of CIT for all the support. Thank you, one and all.
Thank you, ma'am. Thank you, everyone. Let's all remember that yesterday is not ours to recover, but tomorrow is ours to win or lose. Thank you.